Welcome back to the deep dive. Today we're going to pull a crucial tool out of the shadows. We are doing a deep dive into GitLab Snippets, a feature that, it often hides right there in the margins of the application. It looks simple, but it's actually a game changer for speeding up collaboration and maintaining code quality.
It's so true. Most developers, they encounter snippets, maybe use them once for a quick note, and then just dismiss them. They think it's just a digital scratch pad. But the technical depth there is what's much more robust. It really earns the attention of anyone serious about low-friction knowledge sharing.
Okay, let's unpack that right away for you. At its heart, a snippet is just a piece of code, right? A script, a config block. So why not just use a standard full Git repository? What's the real practical difference between committing, say, a 3-line script to a new project versus just creating a snippet?
And that question, that's the key. That's the key to understand the value here. A full Git repository. It requires overhead. We're talking about boilerplate files you have to have, setting up a proper project structure, maybe even a basic CI/CD pipeline.
Right, and navigating the whole formal merge request process just for a tiny change, it's heavy.
It's heavy lifting. Exactly.
So if I've only got, I don't know, a tricky regular expression I want to share or a custom function, I don't want to spin up an entire project for that.
Precisely. Snippets are that ideal middle ground. They're really designed for repeatable, discrete blocks of logic. They give you the benefit of version control and collaboration without all that time cost and the heavy structure of a full repo.
So like a frequently used data cleaning script?
Yeah, or a standard Kubernetes configuration template, something many people need to reference, but nobody needs to track in some massive feature branch.
Okay, that immediately clarifies the why. It's all about avoiding that technical friction. But for maximum efficiency, why wouldn't I just, paste that script into a Slack channel or a tool like Pastebin?
Because those tools don't give you context. They don't give you collaboration, and critically, no version control. GitLab Snippets connect that small code block directly into your development environment. So you get syntax highlighting, you get inline commenting, and the ability to track history features a simple text sharing service just completely lacks.
That makes perfect sense. Okay, now that we've got the motivation down, let's look at the architecture. The source material points to 2 major categories: personal snippets and project snippets. How do they differ?
It really comes down to the home of the code and its intended audience.
Okay, start with personal snippets.
Personal snippets are, well, they're completely independent. They belong only to you, the user, and they live outside of any specific project. Think of them as your private collection of utility scripts, functions, or configs you use across different teams, or maybe even on side projects.
So they're universal in my account. They follow me everywhere on that GitLab instance.
Exactly. If you have a specialized shell script you use every time you set up a new environment, but it isn't tied to one team's project, that's a personal snippet.
Your global tool bag.
Precisely. Now, project snippets are the opposite. They're contextual, they're created, and they live right inside a specific GitLab project. So they're tied to that project's ecosystem, and their visibility, public, private, or internal, usually just mirrors the parent project's settings.
That ownership distinction is huge because visibility is the lever for collaboration. So you have those standard settings: public for everyone, private for just you, and internal for your organization. If you're leading a large company and you need to optimize how knowledge gets shared across hundreds of internal teams, where's the sweet spot?
You should be focusing heavily, and I mean heavily, on personal snippets set to internal. This detail is so often overlooked, but it has massive implications for efficiency and security.
Okay, how does that scale up?
When a personal snippet is set to internal, it means anyone logged into that specific GitLab instance, so every single employee with access can see it. This turns a simple feature into a huge enterprise-wide tool for something called Innersourcing.
Innersourcing, so sharing knowledge and code internally, right?
Absolutely. It lets the entire organization build a collective library of tested, helpful scripts, complex configs, common bits of infrastructure code. You get all the benefits of open source collaboration. People can discover, reuse, suggest improvements, but it's all safely ring-fenced inside the company.
And you avoid the security nightmare of managing public access for what are really internal tools.
Exactly. It's a resource that can benefit thousands of internal engineers without the security headache.
That's a powerful organizational tool. Okay, let's move from just viewing the code to actually working on it. How do snippets facilitate true collaboration? Because GitLab's real power is that feedback loop.
The feedback loop is what makes this so much more than a shared file. You don't just view a snippet, you can comment on it. And crucially, you can comment line by line, just like a full merge request.
So I could literally highlight line 17 and ask a question right there about that syntax.
Entirely. And this creates a really powerful, lightweight, a sandbox for code review. Imagine this scenario. A junior developer is working on some complex optimization problem. A piece of their code is running slow. They don't have to formally commit that code, push it, create an MR, wait for the pipeline.
Which could take, what, 20 minutes before anyone even sees it?
At least. And the pipeline might fail for some totally unrelated reason, which just confuses the issue.
Right.
Instead, they just copy that problematic algorithm into a snippet, share the link, and immediately a senior dev can jump in and leave a precise, actionable comment right on the line causing the problem. Something like, hey, the nested loops here are inefficient, try swapping this for a dictionary lookup. The process is instant, it's focused, it's low friction.
I see. So it acts as this rapid, context-specific mentoring tool that just completely bypasses the formality and the weight of the full Git workflow. That's a massive time saver.
It's speed, it's focus, and it's mentorship all in one feature.
Okay, this is where we get to the really deep technical insight. The one that, for me, makes this a powerhouse. The source material reveals that snippets are actually mini Git repositories. That one fact just changes the entire value proposition. How can you leverage this hidden architecture?
That's the pro-level insight, for sure. And it's foundational. When you create a snippet, GitLab is, in the background, silently initializing a tiny Git repository. It might just have one file in it, but it's a genuine, fully functional Git repo.
So what are the technical implications of having a whole Git structure under what looks like a simple text block?
Oh, the implications are huge. It gives you full enterprise-level features on these tiny bits of code. First, you get full version control. Every single time you update that snippet, the history is visible. You can see previous versions, you can see diffs, and yes, you can roll back to an older version if you break something.
But the killer feature has to be command line access.
Absolutely. The second, and maybe the most powerful implication, is that you can clone that snippet. You can clone it right to your local machine using SSH or HTTPS, just like you would with a massive project.
Wait. I can locally execute and debug a snippet before I push an update back. What does that workflow even look like?
So say you're working on that performance-optimized algorithm. Instead of trying to test it in the main project, you clone the snippet, run it locally with your test data, make your changes, and once you confirm it works, you just push it back up to GitLab. It turns these shared utilities into truly executable, manageable code blocks. They're not just read-only text files waiting to go stale.
That ability to treat a 3-line script with the same management rigor as a gigabyte-sized project, that's fantastic.
It is, and the architecture keeps getting better. There's a really important development to note here. Since GitLab 13.0, snippets now support multiple files. You're limited to 10 files total, but that was a huge quality of life improvement.
Why is multi-file support so critical when we're talking about small code?
Because small scripts often have, necessary dependencies or related configs. You might have a Docker file, but it's pretty useless without the associated configuration file or in .env.example. Multi-file support makes sure you keep those related bits together. It groups the context. It minimizes confusion. The person who clones the snippet gets the entire operational package.
That contextual grouping is so key to avoiding ambiguity when you're sharing things. Okay, let's talk about integration outside the developer interface. How do these snippets work with tools like internal wikis or documentation?
This is where the embedding feature comes in, and it's a massive win for preventing what we call documentation rot. If your team maintains an internal wiki or a knowledge base where you reference code examples, the snippet can be embedded directly into those pages.
So I'm not copying and pasting, I'm embedding the live source-controlled code.
Exactly. You're creating a single source of truth. The crucial part is, whenever someone updates the source code of the snippet in GitLab, maybe to fix a bug or update a command, the code displayed on the documentation page updates automatically. This completely eliminates manual copy-pasting, and more importantly, it stops that disastrous scenario where your documentation is referencing a script that's broken or just doesn't work anymore.
We've all been there, trying to debug a script from a doc page, only to realize it's 6 months out of date. This solves that permanently.
It's a powerful administrative feature that just dramatically improves reliability across the entire organization.
Okay, as we wind down this deep dive, let's make sure everyone walks away with a really solid understanding. If we were to distill this down to the absolute must-knows, what are the key takeaways? And that includes the limitations too.
Yeah, we can summarize it all into three essential points. First, the technical foundation. Never forget that snippets are real Git repositories. They have version control and they are clonable. That gives them a maturity far beyond a simple text file. Second, the types and targeting. You have to know the difference between a personal snippet, which is global to you and great for that inner sourcing, and a project snippet, which is local and contextual to one repo. You choose the type based on the audience.
And the guardrails. What are the limitations that remind us this isn't meant to replace a full repository?
And that's the third point. Limitations define the use case. They're small for a reason. They don't support Git LFS large file storage because they're not for binary assets or huge code dumps. They are strictly limited to 10 files and a 50 megabyte size limit. This reinforces the whole design intent. They're for concise blocks of logic, not miniature software projects.
They really are the small but mighty tool in the GitLab arsenal. They pack the power of real version control and collaboration into these tiny, manageable packages. That was an incredibly clarifying deep dive. Thank you for walking us through the technical depth of what looks like such a simple feature.
Always a pleasure. Understanding the mechanism behind the tool is, it's the key to maximizing its value for your team.
And as you reflect on this new knowledge, here is one final thought for you to explore. If Snippets offer such low-friction feedback on small, isolated code blocks, allowing for that instant peer review and discussion, how might this change the culture of quick technical advice and mentoring within your team, compared to the formality and the whole process required by a full-blown merge request for every small piece of shared code? That's all the time we have for this deep dive. Thank you for joining us, and we'll see you next time.